Yes, sir.
Yes.
So we'll start with a discussion of the paper 4 mock. This is a set 1, paper 4. In the first question, an aircraft pulls a glider along a runway, as you can see on the screen. And a figure 1.2 shows a speed time graph. Whenever we see a speed time graph, we can relate the acceleration by the gradient or the slope. So describe the motion of the glider in the first 12 seconds. So this motion is having two parts. The first part, you can see that it is a straight line for first 6 seconds. When it has a straight line, what does it mean for a speed time graph? The straight line means it has a constant acceleration. So it has a constant acceleration from 0 to 6 seconds. And then from 6 seconds to the 12 second, what will happen? The speed is not changing. As the speed is not changing, we can say it has a constant speed or zero acceleration. So it accelerates or the speed increases from 0 to 6 seconds until the speed is constant and it has a zero acceleration or no acceleration. So whenever you see a speed time graph, you will use the term acceleration to explain. And if you see a distance time graph, you will use the term speed to explain the graph. In the first 6 seconds of motion, there's a resultant force on the glider. The resultant force is 1800 Newton on the glider. The speed increases using the increase in speed for the first 6 seconds. Calculate the mass of the glider. So we have the formula F is whenever you see a 3-mark question, what this given indication? This given indication that there should be two formulas to solve that. So we have to use the two formulas. The first thing, F is equals to ma, force is equals to mass times the acceleration. So m is F divided by a. How to work out the acceleration? Acceleration is a change in velocity over time. So for the first 6 seconds, you have to use your graph. The graph, as you can see on the graph, the maximum speed is 22. That's why we use 22. So acceleration is what? Acceleration is a change in velocity, final minus initial divided by time. The final velocity was 22, the initial velocity is 0, and the time interval is 6 seconds. So this is an acceleration, and then using the force divided by mass, the resultant force is 1800. Force divided by acceleration will get the mass. So resultant force is 1800 and the acceleration is 3.66. So we'll get but whenever you write the answer, try to write your answer in three significant figure. So it is like 491 kilogram. So we can write 491 kg. If you don't round off, that is fine, but write the answer in three significant figures. Determine the distance traveled by the glider in the first 6 seconds of a motion. This is look, whenever you see a question in which a speed time graph is given, so speed time graph, the area under the graph will give us the distance traveled. So you will draw a line for first 6 seconds, and this will be the distance traveled by this plane, which is a triangle. The area of the triangle, it will be a half base multiplied by height. So base is equals to 6 and the height is 22. So half 6 times 22. That will give us about 66 meter is the distance traveled by an object. The glider has no engine and stays in air with the use of a convection current. What is meant by a convection current? So convection current is refers to a motion or the movement of the molecules due to the difference in the density. When like hot air, convection current is refers to a movement of the molecule due to a difference in density. Like example, if we have a liquid and we heat a liquid, so the and molecules with a high energy, the most energetic molecule with a high energy, they will have low density, they will rise up, and the molecules with a high density, they will sink. This movement is called a convection current. So state what is meant by a convection current. Convection current is actually the movement of the molecules due to difference in density, or you can also refers to temperature. That is known as the convection current. Suggests how the convection current suggests how the convection current that support the glider is formed. So how this the formation of the convection current or the glider, how it is formed. So what actually happened? Because the heat energy from the sun will heat the air. When the heat energy from the sun, it will heat the air. So the hot air will rise up. And as a result, so we just have to explain how it is formed. And the cold air will move down, which is having a low density. So suggest how a convection current that support the glider is formed. So how the convection current is formed. So we'll mention the hot energetic molecules which are having a low density will move up, and the cold less energetic molecules will sink, which apply the pressure on the glider and support the glider. Like example, this is a glider. So how this glider is supported? So the hot air is moving up, cold air is moving down. So continuously the hot air is hitting the glider, so which is providing an upward force balanced with that weight which is downward. That's why the glider will remain in air. So only one mark, you just have to refer a difference. Like you don't have to explain the weight and the upward force. You just have to refer a difference, mentioning that the difference in the density, the hot energetic particles will have low density, will move up. So if we mention heat generated from a friction between the tire, the hot air rays, and yeah, if you mention this answer, look, if you mention this answer, this is also a good answer, but it's of one mark. So which point will score the mark for you? Heats the air and hot air rise. It should be rise here. And the cold air sink. This is what will score the mark because it's a one mark. If it was 2 marks, then the whole procedure should be written. So how it become hot, that is not the reason. We don't have any marks for that. The only marks distribution is only for difference in the density. The next question, in a safety test, a car of a mass 1100 kilogram travel at a speed of 10 meters per second collide with a stationary van of a mass 3000 kg. After the collision, the van and the car move together. Whenever you see such question in which the objects are colliding, you will always use a conservation of the momentum to work out the speed. What is the total momentum before is equals to total momentum after. First, they ask define the term momentum. So how we define the term momentum? Momentum is a product of mass and it is a product of mass and velocity. So mass times velocity. What is the unit of the momentum? Unit of the momentum is kilogram meter per second. So the total momentum before should be equals to total momentum after. Momentum is actually represented by letter P. So you should use Newton second. Newton second, yes, it's equivalent to Newton second, but Newton second is mainly used for impulse. Even the unit of impulse is also kilogram meter per second. Newton second is not wrong unit. The base unit, when we represent something in a base unit, we write kilogram meters per second. Can I say momentum is multiplied by distance traveled? No, you cannot say mass multiplied by, mass multiplied by distance travel, mass multiplied by displacement in a unit time, not distance. So because its object is colliding, so total momentum before should be equals to total momentum after. So what is the momentum before? It is 1100 times 10. So this is 1100 times 10. Momentum is not a quantity of the motion. You cannot say that. So here you have to use a conservation of the momentum. Momentum before should be equals to momentum after. So what is the momentum before? The collision 10 into 100 and the mass is 110 multiplied by speed is 10 plus the mass is 3000 and the velocity is 0. No need to put bracket here. Then the mass, because they stick together, so this is 110 and this one is 3000. So what is the total? It will be 100 and, sorry, 1100 times the velocity is v, and this is 3000 and the velocity is also v. So when we add, it will be 4100. 4100 is multiplied, other side it will be divided. So when you divide 4100, this is not correct. Why this is not correct? Because 4100 is multiplied, so this should be in the denominator. So the velocity will be 11,000 divided by 4100. That's the answer for this. 11,000 divided by 4100. 2.68 meters per second. 2.6 is meter per second. Don't round off these answer to a large value. So 2.68, just write three significant figure, 2.68. How we know whether we have to convert SI unit of a mass is kilogram. So whenever you see a mass in the question, it should always be in kilogram. Calculate the total kinetic energy of the car and the van after. So the mass of the car and the van together, because they stick together, the mass of the car is 1100 and the van is 3000. So the total mass is 4100. And the speed which we calculated moved together 2.68. So 2.68 square times 4100 divided by 2. When the answer is too large, what's the best way? You represent in exponent. So on your calculator, there is a button ENG. So you press that button, it will convert directly into the scientific form. So if point is here 1, 2, 3, 4, so I can say 1.47 into 10 to the power 4 joules. Or 14.7, but don't write 2 here. Why? Because we want to represent the answer in three significant figure. So then mention 14.7. State the transfer of energy that occur in the collision. So kinetic energy converted into heat and elastic strain, you can also say. Why? Because if you see when objects collide, they deform. So deformation is there. So you kinetic energy converted into elastic strain, and you can say kinetic converted to heat and strain energy or elastic strain energy. And but the thing is, because they still continue to move, as you can see in the question, that when they collide, they're continuing after the collision, they're still moving. So the total kinetic energy, as the question is, state the transfer of energy that occur in the collision. Transfer of energy, the kinetic energy of the car converted into kinetic, because they are still moving, converted into kinetic energy of the car and the van plus strain and heat energy. So what is the kinetic? Initially, it will have only kinetic. It was moving. Then it is moving, so it has kinetic. Due to a collision or a friction, it will also produce heat or thermal. And during a collision, like the object deform when they collide, so it will also have a strain energy. Why the strain energy? Because the object when collide deform, deformation means object compress, stretch, they always have a strain energy. Chemical energy you cannot say here. Uh, if you start like, then you have to list. They just ask during a collision. They did not ask what is the overall energy. So overall energy, first a car will have a chemical energy of a car converted into kinetic, then it collided, so it converted into kinetic, but you're not supposed to start with the chemical. They ask only during a collision. So during the collision, the car was moving, so car was having a kinetic energy. So you should state properly that the kinetic energy of the car converted into kinetic energy of the van and the car plus the heat plus the strain energy. Figure 3.1 shows a circuit containing three resistors, a 12-volt supply, an ammeter. Calculate the current in 400 ohm. Actually, the current in the 400 ohm resistor is the total current. Even if I say calculate the current in 200 ohm resistor, or I say calculate the current in 100 ohm resistor, because they are connected in series, so the current is same in series. So it is irrespective. So first what I have to do, I have to find the total resistance of the circuit as they're connected in series. So 400 plus 200 plus 100. So the total resistance will be 700 ohm. That's a combined resistance. And I have the voltage 12. So I'll use a formula V equals IR. V is the total voltage, which is 12. I is the current and R is the total resistance, that is 700. So 700 is multiplied, other side it will be divided. So 12 divided by 700. What is the answer? So answer is 0.017 ampere. Calculate the power. Now, if you need the power, we know the current here, as we worked out, the current is 0.017 ampere, and we have the resistance. So power is having different formula. Why didn't we use 400 ohm as a resistance? Look, that's a good question. Why we did not use a 400 ohm as a only resistor? Because 12 volt is a total volts. If I know the voltage here, if I know the exact number of a value or a voltage here, let's say the voltage here was 7, example. So I will use that voltage and I will use the resistance and I will find the current. Can't we? Yes, you can divide the voltage. No, it will not divide evenly. Why it will not divide evenly? Because these resistance are different. If these resistors were identical, if this was 400, this was also 400, then it will divide evenly. It will be 4, 4 and 4. But because they are uneven resistance, one is 100, another 200, another 400. So the resistance is different. The voltage will also be different. Total will be 12. The EMF will be 12. But like total potential difference will be 12 as the EMF is equals to 12. So if I have like this is 400, 200 and 100. So the ratio, what is the ratio between them? 4, 2 and 1. If all were 200, then they will have the same voltage. Like example, if 200, 200, 200, then this will be 4, this will be 4, this will also be 4. So it totally depends on in series. If we have identical resistors, the voltage will divide evenly. But if we are not having identical resistors, then the voltage will divide uneven. So because we don't know the voltage here, that is why when I use the formula V is equals to IR, I did not substitute like 400 because I use the total voltage 12 and I use the total resistance which is 700. So I got the current 0.017. Why I did not use the resistance 400? Because I don't know what is the voltage across the 400. If we were knowing the voltage across the 400 ohm, yes, I can use the formula and I'll get the same result as 0.017. And as they're connected in series, the one with the high resistance will have more voltage and the one with the low resistance will have less voltage. Then we need the power. We just use a formula. We have the resistance and the current. We can use a formula P is equals to I square R. We know the current is 0.017 square and the resistance is 400. So 0.017 times 400. So 0.017 times 400, that will give us the power dissipated, which is 0.12 watt. 0.12 watts is the power. Point 113, I guess it was there. That's why 0.12 is rounded off. A student uses all the components shown in figure 3.1 in another circuit. She connects them so that there's a large current possible in each resistor. So if we want a large current, if we want a more current, so what we want the circuit resistance to be low. Because when resistors, can we use formula P is equals to, why we cannot use a formula P is equals to V square over R? Because we don't know what is the voltage across the 400 ohm. I don't know what is the voltage here. If I try to use a formula P is V square over R, this is 12, but not the voltage across the 400 ohm. That's why I cannot use this formula. So we want the maximum current in the circuit. As we want the maximum current, so we want to reduce the resistance, and how a circuit resistance can be reduced by connecting them in parallel. So what we will do, we will connect the three resistors which we were having, a 400 ohm, any order you can connect, 200 ohms and a 100 ohm, all connected in parallel, because in parallel the combined resistance of a circuit decreases, so the total current will increase. And we'll have a supply of a 12 volts and all components are there, an ammeter. The current in one of the resistor is large than the current in other two. The student connect an ammeter in the circuit to measure the current in this resistor. So which resistor will have the highest current when they're connected in parallel? The one which is having the least resistance will have the most current.
100.
So which one?
100.
100. So I should connect an ammeter here. So we connect an ammeter here. Then, and the voltmeter is also there. The purpose of a voltmeter to measure a voltage. So we'll have a voltage. We connect a voltmeter in parallel. Yeah, this is also fine. If you connect like this way, this is also correct. But ammeter should be there across the 100 ohm and the voltmeter, as voltmeter is also part of the circuit. No, voltmeter was not there. So no need for voltmeter. I thought there's a voltmeter in the question. So you just have to draw an ammeter. No need for voltmeter as it is not there in the first circuit. So ammeter should be in series with a 100 ohm resistor. If I connect two series and one parallel to them. That is not the right way, because the question is why we cannot draw a series circuit here, because already the series circuit is drawn. In the question, this is a series circuit which is already drawn. And according to a description, if you see a description of the question, if you see a description of the question, they mention student connect another circuit. She connects them so that there's a largest current possible. If we want a large current possible in each resistor, it means we want to reduce the total resistance of the circuit. And total resistance of the circuit can only be reduced by connecting them in parallel. So if you connect like this, two parallel, one series, that is not acceptable. If you connect two series, one parallel, That is also not acceptable. It should be all in parallel. So 1 mark is for drawing the parallel resistor, 1 mark is for connecting an ammeter across in series with a 100 ohm resistor. Next is question 4. A student pushes a drawing pin into a wooden board as shown. There is an area of the pin in contact with the finger, which is 5 into 10 to the power minus 5 meters square. That is the area. And the force is 26. Yes, always write a formula. Whenever you are solving a question, always write a formula or show substitution in the formula. Whenever you are solving a question, always write a formula, okay? So it is force, 1 mark is for force over area or numerical substitution. Like let's say one student wrote this, he will score 1 mark, or another student wrote this only, he will also score a mark. Like mark is either for showing a formula or showing a numerical substitution in the formula. And then the second mark is for the answer. The exponent is not correct. It should be exponent 5. 5.2 exponent 5 should plus 5 should be there, Pascal. When you divide them, frequency is number of oscillation divided by time. No, it should not be minus because it does not make a sense. As you can see, it is 26 divided by 5 into 10 to the power minus 5. So this 5 into 10 to the power minus 5, when it move in numerator, it will become plus 5. So actually it is 26 divided by 5 into 10 to the power 5. 26 divided by 5 is 5.2 and 10 to the power 5. That is in Pascal. So when you substitute the exponent, substitute correctly the exponent, compare the force exerted by the finger on the drawing pin with the force exerted by a drawing pin on the wooden board. So when you compare the force, it's not about the pressure, it is about the force. The force will be same. Compare the force exerted by a finger on the drawing pin with the force exerted by the drawing pin on the wooden board. Look, let's say if I push something with a force of 5 Newton, how much the pin will apply a force? The pin will also apply a force of 5 Newton. So the force will be same. If you push any object like there's a nail and you hammer the nail into a ground example, if you apply a force of 10 Newton, the nail will also apply a force of 10 Newton on the ground. The force will be same, but what will be difference? The pressure will be different. Because here the drawing pin, this part is having a large area. So if it is having a large area, here the pressure will be low. But this part is having a small area, so the pressure will be high. So the pin will apply more pressure as compared to what pressure we apply on the pin. But the force will be same. So compare the force exerted by the finger on the drawing pin with the force exerted. So it should be same. And explain why the drawing pin goes into the wooden board but not into a finger. So you will mention here the area in the contact, the surface area which is in contact with the finger is large. So because it is having a large surface area in contact, so the pressure will be less. But the pin on the wooden board is having a small area in contact, so it will apply a large pressure. That's why the pin will go into or goes into the wooden board. Is it clear, this one? In part A3, is it correct answer as it pointed end of a pin is forced by a finger? But the student put his finger on the top, which is in pointed. No, you have to relate in this question specifically, specific term which will score the mark is the area, surface area. So if you mention like road pointed to, so main thing, look, the mark distribution, the main part which scored the mark is referring a surface area, like a small surface area in contact. So there is a large pressure. That is what scored the mark. Is it okay if we just say area? If you just say area, but you have to relate. Like an exam, it's of 2 mark. So explain why. So drawing pin goes into the wooden board. If you say the drawing pin is having a small surface area, that is 1 mark. And what is the effect of the small surface area? The small surface area means the pressure will be high. That is another mark. So whenever you see a question, there are specific terms you have to use whenever you answer such question. The second one, figure 4.2, shows water emerging from a plastic bag that contain a number of small holes. Explain why the water emerged from each hole in a direction right angle to the surface. So what is the reason for that? So what is the reason for that? Like let's say you have a container which is filled with a liquid. The particles of the liquid, when we have these liquid particles, liquid apply pressure in all the direction. Liquid push the molecule here, so the liquid apply pressure in all the direction. So what will happen? Why, the question is why the water emerges from the holes in the direction at a right angle. So what is the reason for that? Like these are the water particles inside. These vertical water particles apply pressure in all the direction. So as a result, when they apply the pressure in all the directions, so they push the particles out from the bag, the plastic bag. So how you will score the mark here? First thing you will mention, First thing you will mention that the pressure in the liquid is acting in all the direction. Irrespective of the direction, the pressure act in all the direction. That is 1 mark. The second thing, near at the surface, like if this was a surface, why the particles are coming out perpendicular? It means the pressure is acting perpendicular to the surface. That's why the particles are coming out 90 degree or perpendicular to the surface. So how to score 2 marks here? One thing, the liquid apply pressure in all the direction, that is 1 point. And why the particles are coming out right angle to the surface? It means that at the surface, the pressure on the particle is 90 degree or perpendicular. That's why all the particles are coming out 90 degree. Particles can apply pressure in all the direction, but at the surface the pressure is 90 degree to the surface. That's why all the particles are coming out perpendicular to the surface or the right angle to the surface. So liquid apply pressure in all directions, and at the surface the pressure is perpendicular, which force the particles to move right angle. So 1 mark here, mentioning the liquid apply pressure in all directions. And 1 mark is for mentioning that the pressure at the surface is perpendicular or 90 degree. Is it clear, this one?
Yes, sir.
Yes, sir.
Okay. The next is the hole at A and B are same size. Why the water emerge at a faster from hole A than B? As you can see, this is hole A, this is hole B. The water is coming out faster from hole A as compared to that of hole B. The hole B is coming out slower. What could be the reason? As you can see, the pressure depends on the depth. The pressure exerted by the liquid depends on depth. I have one opening here. I have one opening here and I have another opening here. So this is point A and this one is point B. So point B is having lower depth as compared to that of point A. Point A is having a greater depth. So what is the reason for why the liquid is coming out faster from point A as compared to that of point B? So the reason is point A is having a greater depth of a liquid as compared to point B. So the pressure on a liquid increases with the depth. That's why P will experience a large pressure. So the particles will move faster as compared to that of A. At position A, the particles will experience a large pressure as compared to that of B. Depth is not identical. If you see, like this is filled with the water, let's say till this is the water level. So when you compare this depth, you always compare the distance from the water level. So if you compare the depth, you will find that B is having a smaller depth than A. Yes, I will repeat. The pressure exerted by the liquid depends on the depth. So if like we are holding from here, let's say this is the water level. So if you compare the point A, the depth of a point A is much deeper as compared to point B. So point A is much deeper compared to, no, you don't compare the level like this. Whenever you compare a liquid level, so this is a bag. It's not about the area, it's about the depth. This is a water level. Point A is here. Point B is here. So point A is here and a point B is here. So if you compare the depth of a point B with point A is much deeper in the liquid as compared to that of point A. So point A is having a greater depth. So greater the depth of the liquid, more pressure it will experience. So which will force the liquid to come out at a high speed or a faster as compared to a B, which is having a lower depth. So the pressure will be less on B. So the particles are forced to move out, but at a slower speed. Is it clear, this one?
Yes, sir.
Question 5, we'll start, join from another link, like the same link. The session will end in about a minute, so better join from a link and we'll continue. Can we say also that the holes at A at the bottom of the bag? Yes, you can say that the holes at the bottom of the bag, but you have to relate that the holes are at the bottom of the bag, then it has a greater depth or a greater pressure. Using a term pressure, relating a depth and using a term pressure is scoring a mark here. Yeah, if you say A is at the bottom and B is at the top, that's fine. But the mark is for pressure. As you want to relate a pressure here, it's of only one mark. So the main thing is the depth and the pressure relation is important.